Well, it is my privilege to come for you this evening and talk about the so-called distant starlight problem. And this, of course, is an argument that a lot of times people will try to use to prove that the universe is many billions of years old, to support the Big Bang idea, really as an alternative to what the Bible teaches. And what I want to show you tonight is that it's not really a problem in the sense that it doesn't prove that the universe is very old. Distant starlight does not prove that the universe is very old. And I'm going to show you why that is. But first, let's go over the argument that I hear pretty often, actually. And the argument is that there are galaxies that are extremely far away, and there are. And you see in the image there, that's part of the Hubble Deep Field, a section of the sky that they pointed the Hubble Space Telescope, and we see galaxies at tremendous distances. It's almost incomprehensible how far away they are. Well, secondly, these, based on our present understanding, it should take light billions of years to travel from these distant galaxies to arrive at Earth. But third, we do see these galaxies, which means the light did get from those galaxies to Earth, and therefore, doesn't that prove that the universe is billions of years old since we see these galaxies? I mean, it should take the light billions of years to get here. We see the light, so it must have gotten here. It must be billions of years old. Well, we know that that's contrary, though, to a straightforward reading of the Bible. And so we can't compromise with that. We can't compromise with these sorts of arguments. Not at all. Now, this has been called the best argument against biblical creation or against a young universe. And how many of you have heard someone try to use this argument at some point? Yeah, look at that. Almost everyone. So, yeah, this is a very, very common argument. And I would agree that it is perhaps the best argument against a young universe, but it's not a good argument against a young universe. But first, let's make it very clear. The Bible does teach that God created in 6 days, and Adam and Eve are created on day 6. The stars are made on day 4 after the plants, but before the land animals, and the sea creatures as well. And it's very clear from those genealogies that you love to read before you go to bed, and so beget so-and-so, and they beget so-and-so. It's very clear from those that you can add up those ages, and that creation happened thousands of years ago, perhaps about 6,000 years ago. In any case, not millions or billions of years ago, not at all. And some people have tried to say, well, maybe there's some way we can fit in those millions of years. And of course, they try to squeeze the millions of years often into the days of creation. But it's very clear that those days are ordinary, approximately 24-hour solar days. And it's clear because of the context of the surrounding words. You have contextual clues like night and evening and morning, and you have numbers with those days. And any time in the rest of Scripture when you have these contextual clues, we agree that the days are ordinary days. They're not a period of time. And we better take this section of Scripture very seriously. Because in Exodus 20, where God lists out those 10 commandments written by the very finger of God, one of those, remember the Sabbath day to keep it holy. 6 days you'll do all your labor, the 7th is the Lord's, and that day you're going to rest. Why is that? Because in 6 days the Lord made the heaven, the earth, the sea, and all that in them is. It's also fair to point out that those people who try to compromise by making the days long periods of time are not in any way helping themselves because the order is different. I mean, after all, in the Big Bang secular model of the origin of the universe, you've got stars made and then the ocean is made much later. But with the biblical account, you've got the oceans first, and then stars aren't made until day 4. Again, you have plants before stars. And so just stretching out the days doesn't help you. So, the Big Bang cannot be harmonized with the Bible. It doesn't work. They're mutually incompatible. You can't make them mix. So the question is not how old is the universe, because the Bible gives us that information. The Bible implicitly teaches a young universe. That is to say, it gives us sufficient information that we can estimate the date of creation. Not that it gives us an exact number or anything. But it's clear that the universe is thousands of years old. So the question is not how old is the universe. The question is, how did God do it? How did God get the light from those galaxies to Earth in a few thousand years? And perhaps in a much shorter period of time. And so I have to go into a little bit of philosophy here. Now, I'm no philosopher, but it seems to me we have to ask the question, is this even a solvable problem? Because there are things that are true that can't even be known. It's possible to prove that there are more things that are true than can be proved. Did you know that? And that's always sort of fascinated me. But, well, there are some things that make me think that maybe distant starlight is not solvable, but there are some things that make me think it is solvable. Keep in mind that, first of all, creation was a one-time event, and it's not repeatable. We cannot create a universe in a laboratory and see how it's done and see how light travels and in those kinds of conditions. Can't do it. Creation was a one-time event. And so a lot of origin science is really limited in that capacity. We can't test it, we can't repeat it in the present. And that's just something we're going to have to live with. That's just the way historical science is. Secondly, creation was a supernatural event. And that's something that we can't just overlook. We need to remember that creation was supernatural, and therefore there are going to be some aspects of it that can't be understood scientifically, because the way that God upholds the universe today, what we might call natural law, God's normal way of upholding the universe, God's normal way of accomplishing His will, is not the way that He created the universe. Today, there's a principle of conservation of mass and energy. The amount of stuff in the universe is constant, but that wasn't the case during the creation week. God was bringing into existence new materials, and so we can't just assume that science can necessarily understand all of the things that happened during the creation week, including the creation of the stars and the initial light transit from those stars to the earth. And that bothers people, but that's too bad. That's the way it is. And we shouldn't be ashamed to admit that, really. Number 3 on my list here. God gave us dominion over the earth, and He wants us to care for it. We're to be good stewards of this planet. I mean, the earth is the Lord's and the fullness thereof, but He's given it to us to care for. In order to do that, you have to understand it. You have to understand things if you're going to care for them. And the Bible also tells us not to be like the horse or the mule, which lacks understanding, it says in Psalm 32, and I think that's a biblical warrant for science. I think it pleases God when we try to understand the universe, and as long as we give Him glory for this incredible universe that He's made. So we should try to understand it. But fourth, God is sovereign. God has chosen to make much of the universe understandable to us, but He's not required to make all of the universe understandable to us. I like to say that number 3, the dominion mandate, gives us the right to ask the question, how did you do it, God? And number 4 means God doesn't have to answer if He doesn't want to. We can't demand anything from God. He's God and we're not. But fifth, and the thing that really makes me think that distant starlight probably is one of those issues that can be understood, is if you think about it, history has shown that many of the problems for creation were easily explained by newer evidence. And just think of the litany of arguments against creation that were blown away by the Mount St. Helens eruption. I mean, they used to say that it takes, such long periods of time for rocks to be laid down and canyons to be carved out. And of course, Mount St. Helens laid down many layers of rock quickly and cut canyons very, very quickly. A canyon 1/40th the scale of the Grand Canyon. All this happened quickly. Conditions that would have happened during the worldwide flood. And so we have these very fine layers in the canyon that was formed by the Mount St. Helens eruption. Layers that they used to say take, 1 year and then the next and then the next and so on. No, they happened quickly. And all those arguments, all those old earth arguments were blown away. Blown away. And if you think about it, most of the arguments that people try to use to establish an old earth, most of them deny the worldwide flood, if you think about it. Most of them do. Because a flood could accomplish a lot of geological activity very, very quickly. Now, what I would like to do now is talk a little bit about some possible solutions to the distant starlight issue. And we need to do one equation. Sorry, got to put one equation in this talk at least. But it's an equation you already know. It's the travel time equation. It's an equation you know even if you didn't know that you knew, because it's you've all at some point, I would imagine, most of you have ridden in a vehicle at some point, and you know that if you travel faster, you can go a greater distance in a lesser time. Distance equals velocity times time. That is the average, the time average velocity. And as an example, if you go 60 miles per hour and you travel for 2 hours, you can go a distance of 120 miles. It's easy. You just multiply them out. Well, light is quite a bit faster than your car. Light can go 670 million miles per hour, quite a bit faster. And of course, those are sort of arbitrary units, miles and hour, and 670 is not a really good number. So astronomers like to say it this way. We like to say that light travels 1 light year in 1 year. So a light year is a distance. It's about 6 trillion miles or 10 trillion kilometers. So it's a distance, and light can travel that distance in 1 year. It's important to point out that a light year is not a year. A lot of people hear that term light year and they think it's time. It's not time, it's a distance. It's the distance light travels in a time of 1 year. And so if you look at the equation then, the distance equals velocity times time. If you put c in, c is what we use as the symbol for the speed of light. If c is 1 in units of light years and years, then the distance simply equals the time, you see. Distance equals 1 times time. And that, mathematically, is the distant starlight problem, you see. Because we do see galaxies that are many billions of light years away, and therefore you would think the time it would take for light to traverse that distance would also be billions of years. That's the distant starlight problem. And the first thing that people try to do, I find, is they question the distance. And this is a solution I would not recommend. The claim is that maybe those distances aren't real. Maybe the galaxies really are not many billions of light years away. And I would say that that has a big problem with it, and the big problem with it is that good operational science does confirm that those galaxies are indeed at great distance. You see, a lot of times creationists will look at some of the evidences in astronomy, and they realize that a lot of those evidences are tainted by evolutionary thinking, and that's correct. But I would say that distance is not one that's been tainted by evolutionary thinking. Those distances are established by good operational science. There's no evolutionary content in them, not at all. And there are different methods, by the way, that you can use to determine distances. But there's the so-called cosmic distance ladder, because each of the methods has a range over which it works. Since the universe is quite large, no one method works over the entire range. But fortunately, those methods overlap, and you can build out and find that galaxies are continually further and further away. Galaxies are really very, very far away indeed. And we might be wrong about the distances by a factor of 2 or so, but I don't think we're off by a factor of 1,000,000. And that's what you'd have to be in order for distance alone to solve the distant starlight problem. Even our own Milky Way galaxy is about 80,000 light years across, which, going back to our equation, means you would think it would take light 80,000 years to get from one side to the other. So the distant starlight is an issue even within our own galaxy. So, pushing all the galaxies into a radius of 6,000 light years just doesn't really seem that feasible. Another solution that we would not recommend using, and I won't be completely dogmatic about this, but I would not recommend using the idea that the light was created on its way. And we get a lot of people that suggest this to us. Dr. Lisle, have you ever thought that maybe, God created the beam of light when he created the star? And that really, it's a clever idea, but it has some philosophical problems with it. And you might say, well, the support for this idea is the fact that the universe was created mature. And indeed, the universe was created mature in the sense that it was fully functional. It worked from the beginning. When God finished his work of creation, it worked. And it didn't need time to come to that condition. And I think that mature creation does answer a lot of objections that people have. For example, Adam was created as an adult. He was able to walk and he was able to speak right from the beginning, wasn't he? Today, people need time to grow up to an adult. And if you assumed, erroneously, that Adam came about by the same kind of process that people come about today, namely that he was born and grew up to be an adult, you would get an incorrect estimate of his age. You might say, well, he looks like he's about 20 or 30 years old, when in fact his true age is 1 day, for example. So you see, if you incorrectly assume that something that was supernaturally created was naturally created, you'll get an incorrect estimate for the age. And that's an important lesson, isn't it? Because the universe was supernaturally created. And so that's something we need to keep in mind. And, mature creation might account for a lot of different things, but I don't think it's a good solution for starlight, because we see things happen in space. You see, we see events. For example, we see supernovae. We see stars that occasionally blow themselves to bits. There you see in the left-hand diagram, you see a little blue star there, actually quite a large blue star. And in 1987, that star decided he couldn't handle the pressure and he blew himself to bits. And so over in the right there, you see expanding star jets floating out into space there. That's what you're seeing, a supernova. Well, this supernova is in one of the Magellanic Clouds. It's 179,000 light years away. So it's not within that 6,000 light year radius, not at all, which means if God created the beam of light, then he created the picture of that explosion, but in fact it never happened, you see. And so that's one of the problems with the light in transit idea. If you believe that God created the beam already on its way, it logically follows that that little star you see in the left diagram never existed, and the explosion you see in the right never happened. God just created a picture of it for us. And so I've got a little bit of a philosophical problem with that. And here's the results of that supernova. We now see these lovely supernova remnant, they call that, expanding out into space. That object, if you believe that God created the light in transit, that object does not exist, despite the fact that you see a picture of it right there. And so again, I have a real problem with that. I don't think that God would create pictures of things that never happened, little movies of things that never happened. It's different than God creating somebody as an adult, which is, you have to start somewhere, right? I mean, he either had to start with an adult or a baby. An adult certainly makes a lot more sense. So it's a little bit of a different issue. So we would not recommend that one. Again, it's a philosophical issue, so if you really want to hold to that, I won't argue with you, but I think there are some better possibilities. One of the earlier scientific possibilities that supposes that the light got here by natural means was that the hypothesis of what they now call sea decay. And this is the idea that the speed of light may have been much greater in the past. And this is a really interesting idea. You see, the idea is that we're questioning the velocity in that little equation, the v. The speed of light might have been much, much greater, in which case it could have traversed an enormous distance in a relatively short amount of time, only today slowing down to its present rate. You see, the distant starlight argument assumes that that light speed has always been constant, but perhaps it hasn't been. And one misconception I want to clear up, a lot of people think, well, doesn't that violate Einstein's relativity? Because a lot of people have heard it said that relativity teaches that light is constant, the speed of light is constant. And that's true, but it doesn't mean what you think it means. When they say the speed of light is constant in relativity, they mean that if two people measure the same beam of light, they'll get the same answer, even if they're moving relative to each other. They'll get the same velocity for that light. It doesn't mean that the velocity of light has always been constant in time. Relativity doesn't say one way or the other, whether light is constant in time. So this would not violate relativity. It might be problematic in some other areas of science, but it doesn't violate relativity. And so that's the proposal. The speed of light may have been much greater than it is today. But there are some potential problems with this model. And this is why a lot of creationists have abandoned this idea and think that maybe the answer lies elsewhere. You see, the speed of light is not arbitrary. It is linked to nature. There are a lot of things that depend on the speed of light being just so. And let me give you one example. Another famous equation, E equals mc squared, Einstein's famous formula. And that equation relates energy and mass. E is the energy of something, and m is the mass that something possesses. And those two quantities are related by the speed of light, which is the c in that equation, the speed of light squared, in fact, which is quite large, because if the speed of light is large, the speed of light squared is very, very large. So what that means is that if something has just a little bit of mass to it, it has an enormous amount of energy. Now that's all fine and good, but what happens if we change the speed of light? Well, logically, if light has decreased, if the speed of light has decreased, then that means either energy has to go down or mass has to go up. One of those two things has to happen. And so you might imagine Earth orbiting the sun. It orbits because it's got orbital energy. Well, if the speed of light drops, you might say, well, the energy drops, and so the Earth would plummet into the sun, potentially. And that's not good. Or the other possibility is, well, maybe the mass goes up to compensate for that changing speed of light. And that would work too, but if the Earth and the sun both become more massive, their gravity increases, and the Earth falls into the sun again, you see. So you get sort of the same answer. There's some possible ways around this, though. I mean, perhaps other constants also change to compensate for that. Maybe the gravitational constant decreases, for example, and that would allow the Earth to continue to orbit nicely. So this isn't necessarily a fatal argument, but it is something that we have to take very, very seriously. And there are other possible solutions too. I've heard a number of very intelligent creation scientists who hold to this idea, who think that it is possible for a CDK to actually solve the distant starlight problem. A third point is this testable? What would we expect to see in the universe if, in fact, light has decayed? I'll tell you that I've looked at a lot of images of the universe. There's nothing that shouts out to me that the speed of light has decreased in time. I don't think there's anything that screams out that requires that the speed of light has decreased. It may have, but I don't think we see compelling evidence for that today. Nonetheless, again, there are intelligent creation scientists who hold to this idea, and so my conclusion would be that this is indeed a potential solution to distant starlight, but there are a lot of details that have to be worked out before I would want to jump on this particular model. One that has been very popular lately is the gravitational time dilation model. And in this model, we're questioning the variable t. Have we made some assumptions about how time works? And I guarantee you we've made some assumptions about how time works. The question is, how off are we? You see, a lot of people have this impression that time is sort of absolute and it's the same everywhere, and that is in fact not the case. Time is variable. You can change the rate at which time flows. And so the idea behind gravitational time dilation is that the universe has in fact aged millions of years, while only 6,000 years have elapsed on the Earth. Okay, and so the idea is clocks on Earth tick very, very slowly, while the rest of the universe goes quite rapid, and therefore the light has plenty of time. From the universe's perspective, it trickles along at its ordinary rate, taking millions of years from the universe's perspective, but from Earth's perspective, this would all happen very, very quickly. And so, in fact, this is based on good, solid physics. General relativity has shown that the rate at which time passes is related to the gravitational potential. Depends on other things, too, like velocity, for example. But clocks will tick more slowly when they are in a gravitational well. I had the pleasure of living out in Boulder, Colorado for a number of years, and we have the atomic clock out there that the nation sets its time by, and it was always fun as a local phone call to go up and set your watch to the atomic clock. Kind of fun, but you know what? There's another one at sea level, another atomic clock at sea level. You know, it ticks at a slightly different rate because it's closer to the center of the Earth, you see. It's in a deeper gravitational well, is the term for that. Gravity affects time. A clock on a mountain does not tick at the same rate as a clock at sea level. The clock at sea level ticks slower. Gravity slows down time. If the Earth were near the center of a finite universe, that is, if at some point the galaxies stop and there simply are no more beyond that, imagine a sphere of galaxies with the Earth roughly in the center. It doesn't have to be exactly in the center. But if that is in fact the case, the Earth would be in such a gravitational well, and time would flow more slowly on the Earth than it would in the rest of the universe. And so this potentially could get starlight here in thousands of years as measured by clocks on Earth. And one of the nice features about this model is it allows for interactions that we normally think of as taking many millions of years. For example, here we see two interacting galaxies. Now, if in fact these galaxies were not created this way, then it would take a long time for two sort of normal galaxies to come together and interact this way. And so one of the things that gravitational time dilation might solve are issues like this. So if you think that God would not have created these galaxies already in the process of collision, then gravitational time dilation is for you. That's probably the model that you're going to prefer. So gravitational time dilation is based on the well-tested physics of general relativity, but it uses alternate boundary conditions. You see, folks who believe in the Big Bang assume that the universe is infinite, or at least that there are galaxies throughout, and Earth's position is not special. And if you plug in those boundary conditions, there would be no gravitational well, and time would flow about the same everywhere. But if the universe is finite, and if Earth is near the center of a finite mass distribution, then time will indeed flow more slowly on the Earth. Now, there have been a lot of criticisms of this model. You know, people have said, well, does time really flow slower if the Earth is in a well like that? Well, certainly it would. Certainly it would. And so I haven't seen any really sound criticisms save one. There is one potential problem that I have seen in the literature, and that is questioning the amount by which this effect happens. Is the gravitational time dilation significant enough to get starlight here in 6,000 years? And there have been papers written that suggest that maybe it's not. In other words, the rate at which clocks tick in the outer universe is almost identical as to what they tick here. They're only slightly faster. Of course, if the universe is smaller, that rate would be different because that would make that gravitational well steeper, and so that could potentially solve the problem. But as you expand the universe, that light gets stretched out, gets redshifted, and so the question is, can this model be adapted in such a way that it gets starlight here in 6,000 years in a way that is compatible with known redshifts? And that has not yet been determined. So a lot of people think that we've sort of got it here, and maybe we're on the right track. This may indeed be on the right track, but the details have not yet been resolved. So this is definitely a potential solution to the distant starlight issue. but there are some details to be worked out. It has not been rigorously shown to get light here in 6,000 years, but it will definitely get light here in less than what is assumed in the Big Bang scenario. There are other methods by which you could question time, some of the assumptions that are involved in time, such as alternate synchrony conventions. You see, there's more than one way to synchronize clocks. I mean, if clocks are right next to each other, you synchronize them, which means they read the same time at the same time. You just look at them and you can see if they're synchronized. But if they're separated by a distance, that becomes a little bit more problematic. And in fact, there's no objective way to do it such that everyone would agree. For example, if there are two bolts of lightning that strike, and someone makes the claim that those two bolts of lightning struck at exactly the same time, they were simultaneous. And so we do an experiment to find out. We go in between, we anticipate when they're going to strike, we go in between the two of them and we watch, and we find that they appear to strike at the same time, but maybe we're closer to one of them, so the light would take not as long to get here as the other one. So we have to subtract off that light travel time, and suppose that we conclude that indeed they struck simultaneously. It turns out that according to relativity, if someone is moving relative to me, they do the same experiment, they get a different answer. They would say that one lightning bolt struck before the other one. Isn't that interesting? Simultaneity, two things happening at the same time, is not, you might say it's not an objective sort of thing. There's a standard convention that we use, but not everyone would agree on that if they have a different velocity, for example. But see, there are other conventions that you could use as well. Now let me give you an example of that with one of these word problems that I know you loved to do when you were a kid. So here we got a plane, leaves its departure city at 4 o'clock p.m., and I've done the hard part for you. Based on the speed of the plane and the distance to the destination, it should be a 2-hour flight. So I've computed the time travel there for you. Okay, so you got that? Plane leaves at 4 o'clock, it's a 2-hour flight. The plane arrives at 4 o'clock. Oh, it arrives at its destination at 4 o'clock. Well, what's going on here? Well, any of you who have flown very much, you probably already know the solution to this little dilemma. How could the plane arrive at the same time it leaves? Well, the plane leaves Virginia at 4 o'clock local time and arrives in Colorado at 4 o'clock local time. And I've been in flights where that very nearly happened, where I landed about the same time I leave. It's sort of interesting. The Earth is round, it's curved, and because of that, we find it convenient to use a convention that we call local time, which is where we define the position of the sun to be 12 o'clock when the sun's at its highest point in the sky. And that's a very common convention. There's sort of two conventions that you would use on Earth. You would either use local time or you would use universal time, and we can apply those same things to space. But first of all, which of those conventions, local time or universal time? Universal time would be, if you call your friend in England and you're talking to them, it's the same universal time, but you have different local times, right? Which of those two would be the one the Bible uses? I mean, if you think about it, really the Bible, as far as I can tell, uses primarily local time. It describes events in terms of where the sun is in the sky. I mean, most ancient cultures used local time. They didn't necessarily divide the Earth into distinct time zones like we do today, but if the sun is at its highest point in the sky, that's noon. That's local time. And that's sort of the biblical convention. Not that it's wrong to use other conventions, not at all. And by convention, in England, universal time and local time are the same. That's where they match up. And as you get further and further away from England, the local time and universal time, they sort of diverge, you see. Well, you can apply that same concept out in space. And so, for example, you could have cosmic local time and cosmic universal time, let's call it. And so just as a possible explanation of distant starlight, don't claim that this is necessarily the answer, but it's possible that stars were created on day 4, cosmic local time, and that their light reached Earth on day 4, cosmic local time, in the same way that a plane can leave at 4 o'clock and arrive at 4 o'clock, as long as it's going west. It won't work going other directions. Likewise, this would only work for light coming towards the Earth. But that's the only place we need to get it, really, because God made those lights in the firmament to shine upon the Earth anyway. So this is sort of one possibility for that distant starlight problem. Now, why would you use such a convention? Why would you have time zones out in space like that, aside from the fact that it solves the distant starlight problem? I mean, if that were the only reason, you would say, well, that's sort of arbitrary and that's special pleading anyway. Well, it turns out that if we use cosmic local time, when you see something happen out in space, that's when it actually does happen, by virtue of the way you've defined time. You don't have to subtract off that light travel time. And so that's very convenient. So why use cosmic local time? It's convenient. It doesn't require knowing the distance to the source, which is why, in fact, astronomers do use cosmic local time. They use both cosmic universal time and cosmic local time. For example, when they name supernova, they name it based on the cosmic local time. Supernova 1987A exploded in 1987, cosmic local time, you see. They don't name it supernova 179,000 BC, right? They don't name it that. They don't name it the universal time, the cosmic universal time. So that's one way that you could potentially get light here if, in fact, the Bible is using cosmic local time. If the Bible is using cosmic universal time, this doesn't work. It won't solve it. So that's the real issue. Does the Bible use cosmic local time or cosmic universal time? Well, today, cosmic universal time is considered to be the standard. That's the true time. It's the convention that makes the most sense in terms of the way the laws of physics are constructed. The laws of physics have their simplest form when you use the cosmic universal time. I could convert them to cosmic local and they'd be more complicated. But if you think about it, throughout history, cosmic local time would have been really the standard, wouldn't it? Because that one doesn't require knowing the distance to the source. And in fact, as far as I can tell, virtually all ancient astronomers used cosmic local time only because they didn't necessarily know the distances to the stars nor the speed of light. So when they saw something happen was when they recorded it, you see. So it's cosmic local time. So the suggestion, if you believe in the alternate synchrony convention model, is that the Bible may have used cosmic local time because it best preserves the perspicuity of Scripture, being understood by all cultures and still being understood today. Whereas if it used cosmic universal time, it really wouldn't have been understood until, really the 20th century, 20th and 21st century. So the objection to this model then is, well, doesn't that really mean that the stars were actually created before day 4 and that their light really only, reaches Earth on day 4? But the really implies that one convention is right and the other is wrong, and we've established that these are conventions, that there isn't an objective way to synchronize clocks that everyone would agree upon in every velocity frame, for example. And so I don't think you can actually say that. It is true that if the Bible uses cosmic local time, then the stars were created in shells inward, you see, progressively inward. But it's also true that if the Bible uses cosmic universal time, then the stars were created progressively outward when you convert the other way. So either way, when you convert from one to the other, you get what's instantaneous in one convention is spread out in the other. And so you see, you can't really get around that. So that's a possibility. So the alternate synchrony convention is a natural solution if and only if the Bible uses cosmic local time, which it may. Now, one objection to this would be that cosmic universal time is so natural and it makes so much sense in the laws of physics that God would have really used that one. And I do consider that a good objection. I don't think it's a knockdown, drag-out argument, but it is a possibility. So, and of course there are lots of other solutions as well. And people have proposed that maybe there's some supernatural component to this. After all, God created those stars during the creation week, and perhaps the light reached Earth during the creation week, so supernatural processes might have been involved. It's possible that God supernaturally sped up the universe. That would be easy for God to do, or he supernaturally slowed down time on the Earth, so that from Earth's point of view, the light would not take any time at all to get here, or virtually no time at all. And such solutions have been proposed, and they're entirely possible. And it wouldn't be the only time that God has adjusted time. I mean, there's an example of Joshua's long day. I don't know exactly what God did to the physics there, but I know it wasn't normal. It was something that was rather out of the ordinary. So perhaps an adjustment of time on Earth versus time in space. So such solutions are certainly possible. But I've presented some that involve known processes that are naturalistic. CDK, the speed of light, may have been greater in the past, might not have been. There are some issues there in terms of what other adjustments, what other constants would you have to adjust to make this work? Is it even possible? Would life still be possible if the speed of light's any different? I don't think these issues have been answered satisfactorily. So further research is necessary. Gravitational time dilation is certainly an ingenious possibility. It is indeed possible that light could get from the distant galaxies to the Earth in thousands of years by virtue of the fact that the Earth may be in a gravitational well, and therefore time ticks more slowly on the Earth than it does in the outermost portions of the universe. And the issue here, again, is whether or not sufficient time dilation has happened, and if such expansion can be made compatible with observed redshifts. And then anisotropic or alternate synchrony conventions, time zones out in space. Maybe the Bible uses the ancient method of marking time at a distance rather than the modern convention, in which case stars would naturally be created on day 4 and their light would reach Earth also on day 4 in a very straightforward fashion. And so my conclusion would be that distant starlight does not prove that the universe is old by virtue of the fact that we have three possibilities, and there are many others. Don't take my not putting up a particular model on here as a dismissal of such model. There are other possibilities as well. And therefore, since there are several possibilities, distant starlight does not prove that the universe is billions of years old. Not at all. Not at all. And you might be upset that I haven't given you the answer, that I haven't told you which one is right, and if I knew for certain, I would have told you. But the fact is, this is something that we're still researching. This is good science. And science really thrives on competing models. So it's good that we've got a few different ideas out there and that we can start testing these models by various kinds of experiments, either theoretical calculations or observations out into space. And I don't claim to know everything about the universe. No creationist should claim to know everything. We claim to know someone who knows everything. That's the real issue here. And so what I want to do now is I want to show you one way that we can start testing these models. So this is sort of an avenue for future research. And one way we can do this is with the age-distance relation, or the look-back time of various objects in the universe. And we can compare that with models of stellar aging. You see, there's a natural connection between cosmology and stellar aging, how stars change with time. And you can use one to sort of check the other, really. And so basically the idea is that the age-distance relation is how old is something as I see it at a certain distance. So if I take the Andromeda Galaxy, the M31 Andromeda Galaxy, which is 2.2, 2.3 million light years away, and when I have that picture of it, how much has that galaxy aged in that picture? Is it just 6,000 years? Is it more? Is it less? Remember, time can flow at different rates. So perhaps the galaxy has aged more or less than the Earth, and of course the light perhaps has taken some time to get from there to here. And so those two effects give us the age-distance relation. And so different models of distant starlight give different age-distance relations. With CDK, it depends on when and how the speed of light changed, if it did. Is it a gradual thing? Was the speed of light sort of very rapid during creation and has gradually tapered off? Or did the speed of light decay during the creation week and then stop? With gravitational time dilation, the age-distance relation has not been yet rigorously derived. And so that's one of the things that we would like to see in that model. But it would be negative, which is interesting. See, with the other models, things sort of get younger as you go out, or they look younger at least. With gravitational time dilation, they look older. It goes the other way. And so as you go out, things have aged more in the 6,000 years that have elapsed on Earth. And with the alternate synchrony convention model, I've written down a little formulary for the scientists in the audience if you want to check that out. But it's basically just the time on Earth, the time of the local solar neighborhood divided by the redshift plus 1. So that's in the simplest form of the alternate synchrony convention model, which basically means if a galaxy is very far away, say at a redshift of 1, which is quite far away, then it would have aged, say, 3,000 years in the 6,000 years that have elapsed on Earth. So things get younger as you go out. I should also want to point out that the three models that I've listed here, and again there are others, but these three models are not mutually exclusive. It's actually possible that more than one of them can be right. And so that's an interesting sort of idea, something that we need to pursue. Now, how can we use stellar aging to check this? Well, we can take a look at galaxies that are further out in space, and based on these various models, they will have aged different amounts. That is, different models predict different aging for different distances out in space. And then stellar aging models can tell us how much those stars have aged, and we can look for trends. For example, it is reported in the literature that distant galaxies tend to be slightly bluer and slightly brighter than nearby galaxies, not a huge difference, but a slight one. And if that is in fact the case, then that would mean that stars perhaps go from blue to red as they change with time. Stars do change with time, some of them do anyway. And so that would sort of support, perhaps, if stars went from blue to red, that would support one of the models that has things going younger as you go out. But if stars go from red to blue, it would support one of the other models you see. So you see the stellar aging actually dovetails with cosmological models. Now that's assuming that age is the only effect at distance. It could be that God just decided to put more blue stars farther away from the Earth. So that's something that we have to keep in mind as well. Can't ignore that. Well, there's one other really important point that I want to make. You see, a lot of people think, well, I don't like any of those models, so I'm going to believe in the Big Bang. But you got a problem. Because you see, even if all those models were wrong, and other potential models as well, even if we didn't know how God got the light from those galaxies to the Earth, you can't use a light travel time issue to dismiss what the Bible teaches in favor of the Big Bang, because logically, you see, the Big Bang has a light travel problem of its own. A lot of people don't realize that, but the Big Bang has the equivalent of a distant starlight problem within its own model. And it doesn't actually pertain to distant starlight, but it is a light travel time problem. It's the same issue, and it's called the horizon problem. And the idea is that the universe, when it is very small, again, this is what the Big Bangers themselves teach. When the universe is very small, it has different temperatures in different places. Let's say A is very hot and B is very cold. Now, today, the universe is much bigger. It's expanded out. Today we can look and measure the temperature in different places in the universe, and we find that the temperature of the universe, once you get out beyond sort of the furthest galaxies, the temperature of the universe is very, very uniform, very smooth, to 1 part in 10 to the 5th power, quite smooth. Well, there's a problem though. You see, those 2 points, A and B, would naturally come to the same temperature if they could exchange radiation. If you put an ice cube in your hot coffee, you end up with lukewarm coffee, don't you? The ice heats up, the coffee cools down. They're in contact. They come to thermal equilibrium. Well, it turns out that there has not been enough time. Even in 13.7 billion years, there has not been enough time for light to get from A to B, because those 2 places are so very far apart today, you see. And so this is a light travel time problem. How do you get light from A to B in less time than seems possible? It's a huge problem for the Big Bang, an enormous problem, because the universe is very, very uniform in temperature, very uniform. And so it's the equivalent of a distant starlight problem. So I think hopefully what I've shown you here is that there are several potential solutions to distant starlight. There's not a consensus among creationists as to which of those solutions is correct, but that's not a problem, is it? Because that's good science. Science thrives on competing models, and it's good that we have several out there, and I hope that people will propose even other models, because we can test these various models in various ways, and that's good science. But since there are potential models, that means that distant starlight doesn't prove that the universe is very old. And in fact, I want to give you a little piece of information which you may not know. I read not too long ago that some secular astronomers had measured the size of the visible universe, that is how far we can see, at 156 billion light years. 156 billion light years, which means we can see, that's the diameter, which means we can see 78 billion light years out into space. But how old do they say the universe is? They say it's 13.7 billion light years, you see. So secular astronomers think that light is able to travel 78 billion light years in only 13.7 billion years. So you see, we all agree that light can travel a distance in light years that is greater than the time in years. We all agree on that. So it's not a problem. The question is just how much different. And we know from the Bible, we know the answer. We know that that light got here in thousands of years, and perhaps much quicker. It might have even all been here by the end of day 4. That's certainly possible. So I have some conclusions here. So there are several possible ways in which starlight can travel large distances in a short amount of time. Therefore, the fact that the universe is large does not prove that it's billions of years old. Folks, just because something's big doesn't mean that it's old. Some of you are bigger than I am, but you're not necessarily older than I am, and vice versa, right? It doesn't follow. Not at all. Not at all. The Big Bang has a light travel time problem of its own, so it would certainly be ridiculous to reject the Bible in favor of the Big Bang because of a light travel time problem when your alternative has the same kind of issue. That doesn't make any sense at all. You're shooting yourself in the foot. It's a self-refuting argument. And I want to just point out that the adventure really is just beginning, because I think now is the time where we're starting to see some amazing discoveries in astronomy that are beginning to confirm biblical creation. And we keep seeing these. How often have you read an article where it said something like, well, scientists will now have to rethink their position on such and such, and this latest discovery overturns the previous idea that such and such? How many times have we seen articles like that? And now's the time where God is raising up some really intelligent creation scientists who are thinking through these issues and making some amazing discoveries that are consistent with what God has said in His Word. So I just want to leave you with a sort of this final thought, that when we think about distant starlight and we think about these galaxies that are incredibly far away, at distances that are just phenomenal, and we wonder how God did it. And that's fine. We know it's fine to wonder about things. I think curiosity is God-given. What we don't want to do is say, well, gosh, God, I don't know how you did that, so I'm not going to believe what you said in your word. I don't understand how you did it, so let's modify your word. No, not at all. Not at all. We need to have some humility before our Creator, because God knows an infinite number of things that we don't. No, I think we need to look at those distant galaxies and think, wow, God made that. He made it all in 6 days. Most of it was made in 1 day. Most of it was summed up in the phrase, He made the stars also. All those billions of galaxies summed up in that one little phrase, He made the stars also. Wow, just a touch of God's power, and all those things came into existence. So I think when we think about the distant starlight problem and these very, very distant galaxies, we need to remember the words of the Lord in Isaiah, where it says, "For as the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts than your thoughts." So thank you very much.